All right, now that we've separated this graph in two graphs, the x and the y, the next challenge is to come up with equations for each of these. Okay. Well, you know, when I look at those, I think, well, this one kind of reminds me of a cosine curve. Starts off high, goes down low, goes back up high. Of course, it would repeat itself if I went around again and again and again here. Likewise, this one kind of feels like sine-ish. It kind of starts at 0, goes up, comes down. And that's what I want to do. I want to focus on that. I'm gonna say let's say that this is a cosine curve. It's a little more wiggly than a cosine curve, but I want to just focus on this thing here, and I want to sort of smooth it out. I don't want it to go. I want to take out some of the wiggles. So don't go as high as the high points. Don't go as low as the low points. Just kind of split the difference between them. And so I'm going to draw a curve that sort of never hits the highs, never hits the lows, just sort of goes through the middles. Right? Be careful on the end. I don't want to go up as high as that high. I'm going to round that off. Right? And I look at that thing and I say, well, that definitely looks more like a like just a straight cosine curve. So this is x equals, well, how high does this go? Well, this was up as high as 10. So how much is that? Well, you know, there's a judgment call here. We're going to have to play with it in the end to see what happens. But if that's 10, I don't know, maybe this is 8, right? So that red curve looks to me like 8 cosine t. Now, by saying that, what I've just done is I've said one cycle goes from here to here. So I just labeled that right there at 2 pi. Never before had I said how long that cycle was, but I'm assuming to make this formula easy for me, call that 2 pi. So one cycle, one period is in 2 pi, so that's just 8 cos t. Now, the curve that I want is not that. The curve that I want is wigglier than that. And so what I need to do is I'm going to have to add some stuff on. Well, I look at it and I say, well, here in green here, I'm going to say I'm going to need to add that much on. Well, down here I'm going to draw a graph of what I need to add on. To start with, I need to add on 2, right? I need to add on about that much. And then right here, I don't need to add on anything. So it started off at 2 and it came down to adding on, you know, essentially nothing. Then I have to actually subtract stuff off. The blue curve is actually below the red curve. So I'm going to be subtracting stuff off for a while. There's sort of a maximum amount I need to take off, which I don't know. And then it comes back to here where I don't have to add or subtract anything. And then I'm adding some stuff for a while. And then right there I'm not adding or subtracting anything. Then I'm subtracting stuff for a while, or I'm adding on negatives. And here I'm not adding on anything. And here I'm not adding on anything. And there I'm not adding on anything. And there I'm not adding on anything. Here, here, here. Those are the places where I'm not adding on anything. And then I'm adding on positive stuff and negative stuff and positive stuff and negative stuff. Positive stuff, negative stuff, and positive stuff. That is that green curve. Essentially, if I think of the red curve as the axis and I pulled it straight, then it would, this is the green one. This is what I need to add on to the red one in order to get the blue one. So what is that? It's like, oh my goodness, that looks like a sine curve or a cosine curve. Actually, I guess that looks like a cosine curve to me because it starts up high. This was 2. So it looks like an amplitude 2 cosine curve, but it's got a shorter period, right? How many cycles do I have? I've got 1, 2, 3, 4, 5 cycles of that cosine curve in 2 pi. So that looks to me like it's probably a 2 times cosine of 5t. 2 to get the amplitude, 5t to get the period to be 2 pi divided by 5. Right? I'm going to switch over to the computer right now and see if that actually looks like the appropriate graph. Okay, so I've switched over to my graphing calculator app here and type in y equals 8 cos x plus 2 cos 5x and see if that's anything like it. And here's the graph. Notice between 0 and 2 pi, I'm starting up here, going down, up, down, up, down, up. It's got a similar flavor. I'm a little worried that maybe those ups and downs aren't enough. Let me just do a little experimenting and see what happens if I can change those ups and downs a little bit. If I switch over here, maybe I need more up and down here. So I feel like I want that 2 to be more of a 3. So let me delete that thing and put a 3 in there. But then those would add up to 11. So let me come over here and maybe change that into a 7. So they're still going to add up to 10. So that main red curve that I had, that main red curve, where was it? Yeah, it's maybe not up at 8. Maybe it's at 7, and so maybe that's at 2. Not at 2, but at 3. So the total adds up to 10. I don't know. I'm just I'm doing my best here to guess at what it looks like, but at least I think this is close. Yeah, there, those got a little bit bigger now. I'm feeling like that's probably all right. Maybe I need it more. Maybe I need to go with 6 and 4. Some combination, depending on how big I want. I think those dips need to be. Okay. So there's the X, at least for now. Let's go back over and see about the Y graph now. Again, I'm going to do that same thing of passing through the highs and the lows. I think of that red curve up here as the main flow. This is, if you're out on the water, if you're out on the ocean, there's a couple types of waves. There's the swell and there's the wind waves. I think of the swell as this really long, big wave, and the wind waves are the smaller waves that are on top of that. And you just add them together to get the total wave. Okay. So likewise here, I'm going to take this and smooth it out, not go through the high points, not go through the low points. One thing to be careful of here is that this is not a low point on the end, right? The whole thing repeats itself, so this would come down and repeat itself there. So there's a low point and there's a high point. That's actually a point in the middle. That's where I want that to go through. So I want to go through here and sort of split the differences now between the highs. Each high and low, take the point in the middle, right? Each high and low, take the point in the middle. So just kind of split the difference between those. This high, this low, the point in the middle is right there, right? Sneak right through there. And again, careful on the end. This would repeat itself. So this low, the next high would be up off the end there. So that's actually a point right there. That looks like a sine curve. That definitely looks like a sine curve. If this was up at 10, what's that at? Well, the whole picture, remember, was fairly symmetric. So what's happening in the x direction is probably similar to what's happening in the y direction. My battery's about to die here. How about that? Better finish this video. Come on now, move over. So maybe that's 7. Right? So this to me looks like y equals 7 times sine t. Right? Again, because we up here said that this was 2 pi, that makes this 2 pi. So one cycle of this red curve here is 0 to 2 pi. So that's a sine curve. And then I've got to add some stuff onto it. I've got to add this extra wiggle onto it. Well, how much is that wiggle? Well, right here I don't have to add on anything. Right there I don't have to add on anything. In between I got to add on something positive. Here I don't have to add on anything. In between those two I had to add on something negative. What is it that we have to add on? So I'm going through and finding the places where I don't have to add on anything. And I'm saying positive through there, negative through here, positive through here. That is, the blue curve is above the red curve, so I'm adding something positive on. The blue curve is below the red curve, so I'm adding something negative on. Above, below, above, below. What does that look like? Well, that looks like a sine curve, right? Starting in the middle, going up, down, up, down. It looks like a sine curve. So I'm going to be adding on this sine curve. What's the amplitude? Well, at some point here, they got to both add up to 10. So maybe if that was 7, maybe this is 3. And how many cycles? I see 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles. So that must be a sine of 5t. Let's take a look at that graph now. I'm going to put this in to the graphing calculator. No, it's to the graphing app. Alright, I've typed it in here that I've got y equals 7 sine x plus 3 sine 5x. And I look at the graph, and here's 0 to 2 pi right here. And does it do what we wanted it to do? It's up, down, up, down, up. I think it looks pretty good, and then it repeats itself. Alright, so now what we need to do is to check and see how they work together parametrically. So that's next. Okay, I've entered those formulas that we just calculated into this parametric plotter app that I have. 7 cos t plus 3 sine 7 cos t plus 3 cos 5t for the x, and 7 sine t plus 3 sine 5t for the y. So this graph is the x coordinate there, and no, sorry, that's the y coordinate, and this one is graphed down here sideways. Okay, so there's a cosine curve there, sine curve here, and when I animate it, you can watch and see how they work together to create this. I need to slow that video down here. Let's get a few more frames. There we go. And you can see how each of the functions is controlling its piece. This x coordinate down here is being controlled by the first function. I'm going to scroll up so you can see them again. There we go. And the vertical here, the y coordinate, is being controlled by this function. As we increase t, we keep grabbing a new value off the graph, and we're generating that thing there. One thing I want to do is just to show you a couple things. We started with 8 and 2. 8 and 2 might have been okay, but if I change this to an 8 and a 2, and I change that to an 8 and a 2, the loops become really small. There's loops there, but they're little, and I think the picture that I had drawn had bigger loops. You know, maybe I wanted them even bigger. Maybe this should have been a 6 and a 4. You know, I still got to get them to add up to 10, right? Because that only adds up to 8, and my x's don't get out far enough. So a 6 and a 4, you know, gets that back there. Likewise here, to do a 6 and a 4. I got these really big loops. You know, I don't remember on my drawing. I don't think I had them drawn quite that big, but still, you can see how changing the size of the wiggle part and compared to the main flow creates similar graphs, but aspects of it change. This is this to me is what parametric equations is all about. That you don't start with equations and have to draw graphs. You start with situations, you start with curves, and you're trying to describe them. You're trying to come up with the formulas for them. So here's a method of working it. Separate the graph into a graph of the x, what the x coordinate is doing, figure out what the y coordinate is doing, and then separately look at this graph, come up with an equation, look at that graph, come up with an equation, and what you've done is you've come up with parametric equations for the original graph.